Hello, welcome to chapter 6. We are moving into quantitative continuous data. So back in chapter 5, we worked with the binomial distribution, which was all about quantitative discrete data, and where there were only two outcomes. But now we're going to work with continuous data. But before we do that, we have to do a little bit of review from back in chapter 3 where we learned what a z-score was. A z-score is measured in units of what the standard deviation is. It tells us how many standard deviations the value is above or below the mean. So let's recall. If our mean is 5 and the standard deviation is 6, and suppose we have an outcome of 17, the z-score would be 17 minus 5 over 6 is 2. So this means that 17, the observation 17, is 2 standard deviations above or to the right of the mean of 5. Now, suppose with the same scenario, we had an outcome of 1. That z-score would be a negative 0.67. That tells us that x equal to 1 is negative 0.67 standard deviations or 0.67 standard deviations below the mean. Okay. So just reminding ourselves that when z is positive, it means that the x value is above the mean. And when the z-score is negative, it tells us that the value is below the mean. Okay. So the standard normal distribution is a normal distribution of standardized values called z-scores, which we've been learning about. This is the technical formula for that, which we don't need to learn, but it is here. We've somewhat learned a little bit about the normal distribution back in chapter 3 without actually formally talking about it. The normal distribution is bell-shaped. The mean, the median, the mode are all equal and are located at the center. It's unimodal. There's only one mode. It's in the center. The curve is symmetric about the mean. The curve is continuous. There's no exact outcomes. It's always going to be a section of outcomes in the middle or strictly to the left or to the right. And so the main thing is this is how we're going to denote the normal distribution. Just like for the binomial, we used a B. Notice where my pen is, we're using an N to let the reader know that we're talking about the normal distribution with a mean. This is the mean, and this is referencing the standard deviation. So this tells the reader the mean and the standard deviation. And in ALEKS, we're going to have to normalize all of our situations back to the 0 and 1 z-score so that we can use ALEKS. Okay. So let's go back over the empirical rule we briefly learned in chapter 3. So if x is a random variable and has a normal distribution with mean mu and standard deviation sigma, then the empirical rule states the following: that about 68% of the values will fall between a -1 and 1, so within 1 standard deviation. About 95% fall within 2, and about 99.7% fall within 3 standard deviations of the mean. Okay, and these standard deviations are essentially z-scores. So right now we know the typical ones, the ones that we have here. But in real life, not everything falls at exactly a standard deviation above or below, and so on and so forth. Sometimes it's in the middle here. Sometimes we want to know the top 10% of students, right? That would be the top 10 would be somewhere over in here. We want to know what z-score that would refer to. So we have to have some other ways to do that. And this normal curve is going to help us with that. The shaded area in the following graph indicates the area to the left of x. This area is represented by this probability, the probability that x is less than this x value. So this is sometimes called area. It's called probability. If when we use ALEKS, it will only give us the area to the left. That is the key in ALEKS. You'll see that here at the bottom. We can use Desmos and we can use ALEKS. For our homework, it's going to be using ALEKS. The nice thing about Desmos is you can see it on the curve and on the graph visually to help you kind of understand. But in coding and ALEKS, we're going to be using this less than button. If you want to find the area to the right, sometimes we do want to find that, then we're going to have to use the complement, which we've learned about in probability. So we're going to have to take 1 minus the probability of a less than. So it's important that you know which area you're looking for. Okay. So if you're using Desmos, you're going to use this normal distribution command, and then you have to click on the box for the find the cumulative probability, and then you're going to put in the minimum value and the maximum value of what you're looking for. When we're using ALEKS, we are going to be using this button here. So if you want a less than a probability of and ALEKS is less than, then we're going to be using this for the left area. And if you want area to the right, you're using here. So this would be for a probability greater than X. And this is the probability of X less than X. Okay, so let's look at some examples where we're going to calculate probabilities. It says, what is the probability that a value X is 1 standard deviation below the mean? That is a z-score of a -1, can also be described by the symbols here. Okay, so we want to have the probability that X is less than a -1. Now, we could find that using the empirical table because that's an exact 1 standard deviation, but we want to learn how to use ALEKS. So let's draw what that is. A z-score of a -1 is here. And we're looking for this area here. What is this probability? So it's good to be able to draw the picture of what's going on. So because it's a less than, we can put that into ALEKS just like that. So let's go to the ALEKS screen. You can find the practice. Don't forget, you can find the practice assignment. If you go to assignments, there is a practice assignment just so that you can use the ALEKS calculator. You can do it as many times as you want throughout the semester. And it doesn't matter what the problem is, it's just so you can access the calculator. So we're going to access the calculator, and I'm going to type the button here. That's the probability that Z is less than, and I want it to be less than a -1. And I'm going to hit enter, and there is my probability, 0.1587 when rounded. So if we go back to our paper, this tells us that about 50%, 15.87% of the data falls below or outside of 1 standard deviation to the left of the mean. Let's write that down. Data falls below the mean. If your data is following the empirical data. So remember, that's if your mean and your median are about the same. So let's look at example 3. It says, find the probability that a z-score is bigger than 2.3. So because the z is positive, it's going to be in the right, and it's going to be somewhere over here. And so we want to find this probability or area. So because it's a greater than, in ALEKS, we have to type 1 minus the probability of X or Z being less than. Now you notice up here I wrote X, and here I'm writing Z. These are interchangeable as far as what we're using in ALEKS, the X and the Z. So let's go back to ALEKS to find this. So I'm going to clear that out, and I'm going to type 1 minus and put in my 2.3 because I really want the area that's greater than 2.3, so I have to do the complement. And so that comes out to be 0.0107. And the last one says, find the probability that Z is less than a negative 1.8. So this is one similar to the one we did up top. So we've got it written right here. So let's go ahead and I'll let you practice that once on your own before I type it in. And then we will check. Zero point 0.0359. Good job. Okay. Example 5. Example 5 says, we want to find the probability of an observation being between a negative 2.68 standard deviations and a positive 1.83 standard deviations away. So we want to find this area or probability right here. Okay. So again, we have to remember how ALEKS works. ALEKS is only going to give us, I should say, we want this. So let's highlight what we want. So if I put in the probability of Z being less than 1.83, because I do want left-hand area, that's going to get, this right here is going to give me all of this right here. Okay. So when I do that, let's find out how much that is. So all the way less than the 1.83. Okay, so that is 0.96638. Okay, so all the way to the left of here is 0.96638. Remember, the entire area under the curve is 1. So right now we already know we don't want this. So we're kind of cutting that off. We want everything to the left. Right now we have everything to the left is 0.96638. The other piece that we don't want is this little piece right here. We want to get rid of that because we only want the pink section. So we need to find out how much this section is right here to the left of a negative 2.68. We want to get rid of that. And so that is going to be found by taking the probability of Z less than a negative 2.68 in ALEKS. So let's go check it out. So that little piece that we don't want to the left is 0.00368. And if we take the difference, if we take 0.96638 and subtract 0.00368, we will find out that the piece that we want is 0.9627. So let's go back to our paper here. So the area that we do want is we're taking this and subtracting this. And 0.9627. That's right here. 0.9627. So if you add this area 0.00368, the 0.9627, and if you found this area, that should equal 1. This is what we wanted. 0.9627. Good job. So this is all about, if you know z-scores down below, you can find area and probability up above by using those commands in ALEKS, okay? Sometimes we know area and we want to find the z-score. So we're going to go the opposite. We're going to have area up here and we want to find a z-score. Okay, so to do that, we need to have a way. So let's just look at these for a minute. It says if to the area to the left of 0.0228, then the area to the right is 1 minus that. Which would be 0.9772. So it's important to remember the complements that we've been learning. Example 7 says, if the area to the right is 0.0122, then the area to the left is also the complement, which would be 0.9878. So in here is 0.9878. So we have to really know what a complement is because we're going to be using it in the next few calculations. So there's a way to use Desmos to find a z-score when we know an area, but we're going to learn how to use it with ALEKS because that's what's going to help us on the ALEKS calculator and also further in our calculations in other chapters. Your critical z-value is what that's called. So we're going to be looking for a critical z-value. It's a z-score with an area to the right. Okay, so this little symbol here, I'm going to make it bigger so you can see. It's that. It's called an alpha. And it's when you see this number that represents this symbol alpha here, that's saying that that's the area to the right that we want to find the z-score that goes with that. Now, if we want to find a z-score that's on the left, we have to tell it, we have to denote with the symbols by saying a negative out here, not a negative on the alpha, but a negative out in front. Okay. There's also in the printed notes or formula packet, there is a critical z table in there that we're going to learn how to use in later chapters, but I did want to let you know that there's a table in there as well. So to find these z-scores, giving the area in ALEKS down here, there's 2 ways to do that. If you are finding a z-score given an area to the right, we're just going to use, there's a button where we just put the area in right here, and it gives us that in ALEKS. If we want to find a z-score given an area to the left, then we're going to use that same button, but we're going to type in 1 minus the area, because remember, it only gives us the area to the right. Okay, so we have to remember that. Okay, so let's look at example 8. Example 8 says, we want to find a negative of z of 0.02. So because it's the negative, we want to find where the area over here is 0.02. We want this negative z value. Because if I just put in z of 0.02, it's going to retrieve the area on the right. But I want the negative one. So that means because I want the negative one, I want the negative area, I have to put in Z of 1 minus 0.02 or Z of 0.08. Okay. So let's go to Alex. And I cleared it out. So it's this button right here. And we are going to put in 1 minus 0.02, which is equal to a negative 2.054. So I put in, remember, I put in 1 minus the 0.02 because we wanted the left-hand Z of that. Now, I misspoke. When I said 0.08, I meant 0.98. This should be 1 minus 0.02 should be 0.98. Sorry about that. So that would be 2.054 standard deviations to the left. A negative 2.054 standard deviations to the left. Now, letter B says, find Z of 0.08. That means I'm looking for a Z-score that goes with 0.08 or 8% of my data over here. It's actually very, very small, but I'm drawing it a little bit bigger just so we can see it. That's a positive Z because it's going to be in the right hand of 0. Okay, so we're going to go to Alex again and clear this out and put in Z. And now I'm just going to type in 0.08. And that is 1.405 standard deviations. $1.405. So it's 1.405. Okay. Let's look at a couple more. So let's say I give you this picture here that says we have an area to the right of 0.0461. I want to find the Z-score that goes with that. So there's a few things that we have to know to interpret. Excuse me. One is that Z is positive because I'm in the right-hand side of alpha or of 0. So it's a positive Z. And I'm asking for a right-hand area. That's what it's giving me. And that's what it takes in Alex. So I get to write it just as it is. So we're going to go to Alex and enter it just like this. And there is the Z-score that goes with that, 1.68. 1.684 if you want to go to 3 decimal places. Okay. B is getting a little more complicated. This is our last one for lesson 4.1, but it's a little more complicated. So it says the Z-scores that cut off the symmetric middle 90%. So there's some things in here. We want Z-scores. It said more than one because I put an S. It said symmetric middle 90%. So I don't want 90% over here. I don't want 90% over here. I want 90% in the middle. Not 0.9, but 90% in the middle. So that tells me two things. If I take 1 minus 0.9, that means I have 0.10 equally distributed out here, right? So I have to take 0.10 and divide that by 2. So that means I have 0.05 or 5% here and 5% here. So 5, 90, and 5 is 100. It has to equal 100. Okay. Now, because it's symmetric and we're talking about Z-scores, these are symmetric. So if I'm 1 z-squared to the right, that means I'm a -1 to the left. If I'm 1.7 to the right, I'm a -1.7 to the left because they're symmetric. So I really only have to find one of them. So I can find one of them by saying z of 0.05, because that will give me this one right here, right? Alex will give me area to the right. So I could say z of 0.05, which should match the one that's z of the negative z of 0.05, which would be the one over here, which is going to be the same as z of 1 minus 0.05. Because remember, we want, when it's a negative z, we have to do the complement. So it's really z of 0.95. They should be symmetric, just opposite negatives of each other. So let's go check it out in Alex. So I'm going to put z of 0.05. That is 1.645. And now if I clear that out and do z of 1 minus 0.05, it's going to be the negative. So a negative 1.645. So these are, in fact, just negatives of each other. Negative 1.645 and a positive 1.645. And that wraps up lesson 6.1. Catch me back for the next lesson.